Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Hey, hi everyone. Welcome to this amazing Mastering Dynamic Programming series. And this is our day 2 of the series. I'm very pleased to see you all here. And quickly in the chat section, can I get a confirmation if my voice is clearly audible and also if my screen is clearly visible? All right. Hello, Faisal. Hi, Naikaj. Hi, Satyam. Thank you for the confirmation. So let's just wait for a couple more minutes so that rest of our friends also join. And then we will be starting at 22:05. So today we will be discussing knapsack problems majorly and the questions, the concepts that are revolving around these problems. And in the tomorrow session, we will be dealing with the questions that are based on knapsack. All right. I hope every one of you went through the article that I shared in the last session. So it will be helpful for you to understand the concepts. And a quick overview of the previous session. Basically, in the previous session, we discussed about the timeline that we are going to follow in this series of the dynamic programming, the questions that we will be going to take up, and the method of solving the questions. Like we will be starting from recursion, then memoization, and then we will be using the DP approach. And we discussed the need of DP and how we can identify if a question is a DP based or not. All right, so that was what in the previous session. Today we will be starting with knapsack problems. So, all right, okay. So I guess we are good to start with our today's session, that is day 2. All right, guys. So today we will be basically taking up the knapsack problems. Okay. So let us begin. So first of all, what is a knapsack? We know that, right? Knapsack means, it is basically just a kind of a bag, like, where you can store items or the anything that you want to store. So, a sack or bag, whatever you want to say, that is a knapsack. All right. Now, what it is a very famous DP approach. Okay. Every DP session that we take, the first question that is discussed is always the knapsack question. All right. It is a very famous DP problem because it majorly uses this DP approach. So that's why today also we will be beginning with knapsack. Okay. Now there are three kinds of knapsack that are there. Can anyone help me with that? What are the three kind of knapsack that we have? No one knows? Yes, correct. Correct, Naikaj Faisal. First one is 01 knapsack. And okay, great, Miral. That's correct. Next is fractional. And one more. There is one more kind of knapsack, and that is. Are we not very familiar with it? All right, Dave, it is correct. First is 01, then fractional, and then we have unbounded knapsack. All right. So the agenda for today is basically discussing about knapsack problems. Okay, now, okay, out of these three knapsack problems, one of them uses the greedy approach. Okay, like this fractional knapsack, it basically uses greedy approach and it is not based on DP. Okay, but these two 01 knapsack and unbounded knapsack, both of them uses DP approach. Okay, these two are based on DP approach. By the end of the session, once we have discussed 01 knapsack and unbounded knapsack, then we will be looking for this fractional knapsack as well, that how it is using greedy algorithm. All right, now moving ahead, we are clear for this knapsack, right? Now let me describe what happens in this knapsack problems, how the problem statement looks like. Okay, in the problem statement, in input, a value array is given to you, a weight array is given to you. Okay, the total weight is given to you. All right, and n is given to you, that is the total number of items. All right, this is how the input looks like. Now what is the value array? Value array will say it will have values of the items. Let us say it is 1 2 3, and then it will be having this weight array will have corresponding weight of the items, that is, let us say 4 5 1. So total items we have 3, and w that we have here is, let us say, that is 4. Now let me elaborate this. This is basically the max capacity of knapsack. All right, these are the values and these are the weight of corresponding. Okay, these are always the corresponding values. Okay, just a second. Okay, so these are always the corresponding values. Okay, the item which is having a weight 4 is having value 1. Okay, the item which is having a weight 5 is having the value 2, and the item which is having weight 1 is having the value 3. Okay, so this is, let us say, this is our bag. All right, now in this bag, the maximum capacity that this bag can hold is 4. What do we mean by maximum capacity? That is maximum weight. All right, that this bag can hold is 4, and n is 3, that is total number of items. Clear? So this is how the problem statement looks like, and what basically the problem is, you need to add items in knapsack. All right, such that we get max value. All right, is this entire thing, the problem statement, clear to you all? And also you need to add item in such a way such that total weight of items is less than is equal to W. That is the maximum weight of the knapsack. All right. Okay. So is this problem statement clear to you all? Let me know in the chat section. If there is any confusion, I shall repeat it. We have input in that the 4. Yes, Faisal, I will be discussing it. Why is it called a 0-1 knapsack? Let us first have a clear picture of what is knapsack actually, knapsack problem, and then we will be discussing the 3 types of knapsack and why they are named so. Any problem till now? All right. Okay, so we don't have any issues. Okay, so let us now move ahead. Okay, so as Faisal asked us that why is it called a 0-1 knapsack, so let us help him with that. Okay, so we have 3 kind of knapsack. First is 0-1 knapsack. Now, what happens in 0-1 knapsack is, let us say you have n number of items, all right, and let us say this is a bag. All right, you need to add items in this bag, and let us say we have here total 5 items. All right, 5 items are there, and we need to add it in the bag. Now, what we do is, let us say this is item n1, this is n2, n3, n4, n5. Okay, now what we need to do is you have to select that whether you will be adding this item or not. Okay, based on certain conditions that we will be seeing further, you need to decide that whether this item we need to add or not. Similarly, for this item, you will decide whether you are adding it or not in this bag. Okay, for this item, same choice, for this item and for this item as well, right? So like for each items that we have here, we are making the choice that whether we are going to add it inside our bag or not. Okay, so when you add it, we say it 1, right? 1 is a true, like this item has been added, and when we not add it, we refer to it as 0, right? 0 is false, it means the item has not been added. Okay, so for every item you have 2 choices, either to include them or either to not include them, right? So that's why this is known as 0-1 knapsack. These 2 are the only choices that you can make, either add the item or not add the item. Okay, so is this clear why this is 0-1 knapsack? Let us move ahead. The next kind that we have is fractional knapsack. Okay, now what happens in fractional knapsack is, again let us say we have n items. Okay, and let us say this is a bag wherein we need to add the items. Okay, now in fractional knapsack, what happens is you decide whether you are going to add this item or not, but in okay, in this previous page, the thing was there that in 0-1 knapsack, suppose the weight of this item is 10 kg. Okay, the weight of this item is 10 and the maximum weight that this bag can hold is 8. All right, so you can't divide this item into, like, 10 pieces and then you can add 8 pieces inside the bag. You can't do it. When you are adding an item, you have to add it completely, right? You can't cut it in pieces and then you can add, or you can't add a certain part of it, right? But then what happens in fractional knapsack is, if you want to, you can break an item into parts and then only you can add the part that is required, right? Let us say if this is 10 units, right, and the bag can hold a maximum of 8 units. So, and let us say if this is having a value of 50, okay, and all of them are value of 10, 10, 10, right? So we need to add this item to maximize our profit. So what you can do is you can break this item into 10 pieces, okay, and then you can add 8 units into this, right? The value will also get distributed according to that. All right, so that is why it is known as the fractional knapsack, because there is no bound to add an item completely. Okay, you can break the item and then add it if it is giving the maximum value. But please keep in mind, when you are breaking the item, the value will also get distributed accordingly. That's basically, unitary method. You can use unitary method to find the value of a single unit. All right, so are we clear for fractional knapsack? Why it is called fractional? Because you can add a fraction of an item. Okay, you don't need to add an item completely if it is not satisfying condition. Is it clear? All right. So let us now, third type, that is unbounded. Okay. So in 01 knapsack, the thing was that when you are including an item, okay, once you have included it, you can't add it again. Okay, we only have one unit of each item. All right. Every item is unique and we only have one unit of each item. Yes, exactly, Nikaj. In 01 knapsack, you need to add the whole item. You can't break it, okay? And when one item has been added, you can't repeat it as well. All right. But then in unbounded knapsack, what happens is, suppose you have added one item, like let us say we have 4 items, N1, N2, N3, N4, okay? Suppose you have added N1, but if the situation demands, you can add N1 again and again, okay? That is, repetition of items are allowed. Repetition of items are allowed, okay? That's why it is known as unbounded knapsack. There is no bound on the items that you can add. All right, so are these 3 forms of knapsack clear to you all? And yeah, also I would like to mention it again, that this fractional knapsack, this uses greedy approach. All right, this is not a DP question. It is based on greedy algorithm. Okay. Are these 3 form clears? Okay. Okay, clear to you all? Give me a confirmation. Okay, it is only clear to Nikaj. Okay, Faisal, clear. All right, so let us now move ahead. Unbounded is not greedy, fractional is greedy. Okay. Because in unbounded also you need to add the whole item, so you'll have to make the choice whether we are adding the item or not, right? The only difference in unbounded and 01 is that in unbounded you have repetition of items. Okay. Yeah. All right, everyone. Thank you, Vishal. Now, let us see why this is a DP question. Like first, at very first instance, if someone is giving you this question that a knapsack is given to you and weight and value array is given to you and you need to solve it, so why it should click in your mind that this is a DP question. So can anyone tell me, in the last class we discussed that there are certain characteristics of a DP problem. So can anyone tell me how we can figure out if this is a DP problem? What those characteristics can be seen here? Yes, Nikas, you are absolutely correct. I'm very happy to see that the concepts are getting clearer to you. Alright guys, so I want you to tell me why this is a DP question. Choice, exactly. Choice is there if we want to pick or leave. Great Miral, great Vishal, Faisal. First thing is that we have choice making. Where is choice making? We are deciding, right, that whether we want to add an item or not, okay? Include or exclude. Let us use this word 01 basically, okay? Choice making. What is the second thing that is there? Overlapping problems, all right. And also, can we say this that there is a requirement of an optimal answer? Like we need to maximize something, okay? Either it is maximize, right? We are maximizing the profit. So we need an optimal answer, right? And obviously, every one of you is correct. It is having overlapping subproblem, right? So based on these three things, we can say that this is going to be a DP question. Clear to you all why this is a DP question? Like number of bag is not maximized, Nikaj. Actually, the value inside the bag is getting maximized. Okay. So let me know if this is justifiable to you all. That why is this a DP question? If you all can build an intuition now. Yeah, we need to choose the value. Number inside the bag is getting maximized. Okay. Clear till now? Seems like we are. Now, let us move ahead. Yes, exactly, Nikaj. We need to choose the max value back. Okay. Now, let us move ahead. Okay. Great, Faisal. Thanks for confirming. Now, we are going to solve 0 1 knapsack, first of all. We will start with recursion. Then we will move to memoization. And then at last, we will be looking at DP approach. Okay. Let me draw a cycle. Yes, sure, Vishal, I'll be doing that. First of all, recursion, then memoization, and then DP approach. Okay, that is how the algorithm flows, right? Clear to you all? Recursion will lead to memoization, and then with the memoization, see, if you will directly start doing this DP approach, right? Like in DP approach, we have bottom up or top down, okay? We have this bottom up and top down. All right, so, okay. Sorry. All right, guys, so yeah, if you use this DP approach and if you directly start making tables, then what happens that, there can be some confusion. You might not be able to see, what values are getting changed or how we are filling the values inside the table, right? So in such cases, it kind of becomes difficult to analyze everything. So that's why we will be doing it in a systematic way. Okay, we will be first doing the recursion, then memoization, and then DP. All right, it will help you to figure out the correct approach to the question. So don't jump over directly on this table thing, like the table that we make by running two loops. All right, so don't jump over directly on that. First of all, try to build up the intuition inside your mind. Okay, so if you will follow this method, you will be able to build up that intuition. All right, so now let us first look at the recursive approach. Okay, so let me just write down function outline. Let us say we have a function int knapsack. Okay, now what are the values that is given to us? Let us say that is int w. Weight is given to us. Weight array. Okay, value array is given to us. And n is given to us. Okay, what is n? The total number of items. Okay, now we are going to write down the recursive approach. All right, what is the first condition for a recursive approach? Whenever we write a recursive code, what is the first thing that we do? And actually, rather than doing it here, let me do it directly in the editor. Okay, base condition. Yeah, are you guys able to see the code editor? GFG's code editor. Yeah, base case, that is correct. Uvesh, Vishal, if I can please get a confirmation if code editor is visible to you all. Okay. Is it visible now? Okay, so it is visible now, right? Now, base condition, let us first of all write down the base condition here. Okay, so what will be the base condition? Base condition in a recursive code is basically, at what condition this recursive code should stop, right? So let us say if you are having a bag which is not having any maximum capacity, like let us say the maximum capacity that it can hold is 0. So in that case, there is no any point of adding items. We will not be able to add any item inside our bag. So we can say that if weight is 0, right, the maximum capacity of the bag, or if we have exhausted all the items, right? If you have already added all the items that was given to you, then in that case as well, you need to stop your code, right? So in these two conditions, what we will be doing, we will be simply returning 0. Always check for this, that what is the return type of the function, okay? And then on the basis of that, write the statements. So, okay, is this base condition clear to you all? Yeah, exactly. Either max weight is achieved, or you can say that if your bag is empty, right? I mean, the maximum weight that your bag can hold is 0. If you're, see, in that case, if your maximum weight is achieved, it means that some values has been added, right? In that case, you will not be able to return 0. So that's why for the base condition, what you need to check is that what is the smallest input value that you can use, right? So the weight can be smallest value that the weight can take is 0, right? So we will check that in if weight is 0, then in that condition what answer we will be returning. Okay, so this is going to be our base condition. Next, let us say if weight of the current item is greater than the maximum capacity of the knapsack, right? So in that case you can't add that item. So what we will be returning is simply write down knapsack. The weight will remain the same, weight array will remain the same, the value array will remain the same, and n will be decremented by one value. Okay, is this clear? This is the code when item not included. All right, so as the item has not been included, so the weight remains the same. We are not subtracting the current weight, and see the weight at n minus 1, that is our current weight that we are taking into consideration. Okay, we are having an array of size n, like 1 2 3, right? So we are starting from the last. So let us say this is 1, right? So we will check if 1 is greater than the maximum capacity or not. Okay, so if let us say 1 comes out to be greater than maximum capacity, then we will simply not add it and we will simply move to the previous element. Cool. So is this line 7? Okay, let me enlarge the code editor. All right, is this clear to you all? I need to, yeah, now it will be more clearer. Okay, so is this a statement clear when we are not including the item? Right, clear. Thanks everyone for confirming. Now, let us say the item weight is less than the maximum capacity of the knapsack. Okay, so even in that case, we have two choices, whether we are adding the item or not. Clear? Even if the weight is less, then also you need to find out that whether adding the item or not adding the item will give you the most optimal answer. Okay, so in that case we will be returning, we have two choices, right? So let us say we have added the item. Okay, so when you have added the item, the value will get added. Okay, so value we are adding, all right, plus we will be returning. No, it is not sorted. The array that is given to you is not sorted. All right, now as we have added the item, so you need to remove the weight. Okay, so that's why we have done w minus weight at n minus 1. The weight array remains the same, the value array remains the same, and decremented n. Okay, so we are finding the maximum either this or either when we have not added the item. So when you have not added the item, it will be simply again W, weight, val, and n minus 1. Okay, because we have not added the item. So this is what we are returning. Okay, so okay, let me first check if this is giving the correct answer. Okay, we have a compile error. 18. If we are, is there anything that was supposed to be here? If weight at n minus 1, we will simply return knapsack that is at weight, val, and n minus 1. All right, okay, line number 21, what we are doing is, let us say you have added the item. All right, so when you have added the item, what will happen? The value that the item is having, it will get added. So that's why I am adding the value of the item and I am doing this thing, okay, returning the entire knapsack code as it is with the same parameters. Just what you need to do is you need to add the value of the current item because it has been added. Okay, clear? Like, okay, let me show you once it in the explanation part and then it will be easier. Yeah, let me show it in this. Weight at n minus 1, right? Okay, there is some. Yeah, W minus weight at n minus 1 because, okay. You need to see that if this is a bag, okay, if this is a bag, all right, and let us say the maximum weight that it can have is 10 kg, 10 units, okay? And now let us say if you have added an item which is of 4 units. So don't you need to do 10 minus 4 because now bag can hold only 6 units. So is this clear? While weight at n minus 1, whatever weight you are adding, you need to remove it from the maximum weight, right? Okay, so let me know if this is clear. Try to get this. Try to analyze it clearly why it was weight at n minus 1. Is this clear? Can I please get a confirmation? And also we are decrementing n minus 1, okay? Like now we are evaluating the next item. So that's why we are doing n minus 1. Okay. So shall we now move to the code part, right? Like let us say if it was 1, 2, 3 and value given was 4, 5, 1, right? So now let us say that the bag can contain a maximum of 10 units. So we can add like this is value, this is weight. Let us say we are adding this item, okay, with the value 3 and weight 1. So if this item has been added in the bag, so now how much bag can hold is that is 9 units only, right? Because 1 unit has already been occupied. Why max? Because we need to find the maximum value that we can have. Okay, we need to check that, okay, we have two conditions. Okay, let us say this is an item. Let us say weight of the item is small w. Okay, now let us say the weight of the item is less than the maximum capacity of the knapsack And the second case can be the weight of the item is greater than the maximum capacity of the knapsack. Clear? Okay. Now tell me, if the weight of the item is greater than the maximum capacity of the knapsack, then can you add it inside your bag? Let me know it. And like you all can picturize it, analyze it by yourself. If there is any doubt, you can keep on asking me again and again. I'll be very happy to help. Okay. All right. So in this case, we are very clear that we will be not adding it. Okay. We will exclude this item. Okay. That is 0. Let me show the code again. Yeah. So as you can see, what we have done here is this thing that we have written. Okay. If weight is getting greater than W, all right, in that case, we are not including that item. Okay. And as because the item has not been included, so that's why we are not subtracting the weight from it. Okay. The weight will remain as usual because you haven't added anything inside the knapsack. Okay, so the weight of the knapsack, it can hold 10 units, say, it can still hold 10 units, okay, because no any weight has been added, right? And the weight array and value array will remain same as usual. And once you have not added that item, what you will do, you will move to the next item, okay? So is this line number 17 and 18 clear to you all? Okay. All right, thanks, Ankit. Now, all right, great. Okay, let me stop the screen again. Let me share the entire screen actually. All right. Okay, so is this clear that we will not be including this item if weight is greater than W, okay? Now, second case, what can be that weight is less than the maximum capacity. In that case, okay, if weight is less than the maximum capacity, okay? So in that case, are you going to add the item directly? If the weight is less than the maximum capacity, will you just add it without checking anything? Because adding a weight means the capacity of the knapsack is getting reduced, right? So you just can't add it without checking that. All right, so that's why even if the weight is less than the maximum weight, you need to find out, you will have to still make a choice that whether we need to add this item or to not add this item. Okay, we need to check that whether adding or not adding, which two of them is giving us the max. If you will add it, then you have to subtract the weight. Okay, if you will not add it, then weight will remain as it is, right? So that is what I have done here in line number 2021. Okay, so please look at the code very carefully and let me know if there is still any confusion. Exactly. First, we are checking because see, if the current weight is exceeding the maximum capacity of the knapsack, then there is no any point to check, whether we are adding it or not. We are very clear at that time only that we are not adding this item, right? To call in which line number? At line 22. Okay. So line 22 is to call for this condition. If weight is less than W, okay, see, if weight is greater than W, in that case we have excluded the item, that is clear, okay. But if weight is less than W, then in that case you need to check that whether you are adding the item or not, because let us say if sometimes it might happen, right? Like, let me think of a condition. Let us say the values are 50, 10, 10, okay, and let us say the weight is, let us say the maximum it can hold is 10, the weight is 10, 5, 5, okay, sorry, So you all tell me what is the most optimal way to fill the knapsack if the max capacity is 10. First of all, you will check for this item. The weight is 5. That is less than the max capacity, right? So do you add it? Will you add it inside this knapsack? Just because its maximum capacity is less than, just because its weight is less than the maximum capacity, will you add it inside the knapsack? All right, let us say we have added this, okay? So now the knapsack weight is 5, okay? Value, weight. So currently the value it is holding is 10. Let me use a new page. Let us say this is our knapsack. The weight it can hold is 10, okay? And we have 10, 5, 5. This is for weight. And value is 50, 10, 10. All right. This is value. Now, we have started our iteration from this point, okay? The weight is 5. 5 is less than 10, okay? Now, let us say you have directly added it without checking, okay? Just because the weight is less than 10, so you have directly added it. So, the value inside the knapsack is value inside the knapsack will become 10 and the weight of the knapsack will become 5. Now, in the second iteration, let us say you have added this item also, okay? So, the value inside the knapsack will become 20 and weight will become 10. So now what is the maximum value inside the knapsack? That is 20, right? Now, is this optimal, or if this would have been optimal if you would directly added this 10 units, okay, with the value 50? Because in this case you are getting the max value as 20, but in this case you are getting as max value as 50, right? So did you understand why we need to make a choice even if the weight is less than W? Okay, this thing. Why we are making the choice if weight is less than W. Is it clear to you? Got it? Okay. So now again let us see our code. So this is what our code is doing. At line number 17 and 18, first of all, we are checking if weight is exceeding the maximum capacity of the knapsack. All right. Exactly, we need to add the max value. We need to add the most optimized value. Because here the addition is not only dependent on one thing, that is the value array. You need to take into consideration the weight as well. Okay. There is a constraint on weight. So you need to check that which weight we can add so that we can get the maximum value. All right. So that's why line number 17 and 18, if weight is exceeding, just simply exclude that item. But if the weight is not exceeding, then check that what will give you the maximum value. All right. Adding the item or not adding the item. Okay. So that's why we have these two conditions here. So is this recursive code clear to you all? If any doubt, please feel free to ask. I'll be very happy to help you. Sorry, Vishal, I didn't get that point 10 by 50. All right. So thanks everyone for the confirming. So we are clear now for the recursive code. Okay. And now when I'll try, okay, just a second. When I'll try to compile and run this code, all right, so we are getting the correct output that has been expected. Let us see what will happen if we submit it. All right, so we are getting time limit exceeded, and that is very obvious what we were expecting, because just a second, yeah. So it is very obvious what we were expecting, because this is a recursive code, and obviously recursive code takes much time. Exactly, that is what we are doing. So okay, now can anyone help me? What will be the time complexity of this code, this recursive code? Time complexity as well as space complexity. Satisfied with these two complexities that I have written? Exactly, Nikaj. That's correct. All right, everyone. 2 raised to the power n because two recursive calls are being made. Okay. And space complexity is linear because of the recursive stack that we are using. Okay, as it is a recursive function, so it will use a recursive stack. That's why the space complexity is linear. All right. Okay. Okay, so is this recursive approach very clear to you all? And are we good to start to our next approach? Let me know it in the chat section. Great. Now the next approach that we are going to discuss is Memoized approach. It depends, Miral, actually the number of recursive call that is being made. Okay, here we were making two recursive calls, that's why it is 2 raised to the power n. All right, can anyone tell me what is memoization? And also, what was that famous line that we are saying again and again about DP? Let me show it. Those who don't remember the past are condemned to repeat it. All right, so that's why in this DP approach, what we try to do is we try to remember our past. Okay, so memoization is going to help us with that. Okay, so in memoization, what we are going to do is we will store previously computed values as correctly said by Nikaj. Okay, so we will be storing previously computed values, right? And how we are going to do this? We are going to do it with the help of 2D array. Okay, clear? Now let me show you what we will do exactly. Let us say this is the function knapsack. We have int weight, we have weight array, we have value array, and we have an integer n. Okay, now what happens is you are going to store the value that has already been calculated. All right, so let us say we have created a global 2D array of size say 1000 and 1000. Okay, now how we are going to decide what will be the dimension of this 2D array? What will be the dimension of array actually? That is the second thing, if it will be a 2D, 1D or 3D. All right, in this question tell me what are the factors that are changing. Is maximum capacity of the knapsack changing with every call? Exactly, Nikers. That's exactly what we are going to do. Okay, weight is changing. So it is one dimension that is getting changed. One dimension that is getting changed is W. All right. Is this weight array getting changed with every call? Is this weight array getting changed with every call? Yes. Why weight array is getting changed? Think carefully. With every call, is weight array getting changed and val array as well? Are these two array getting changed? Is this like in one call it is 1 2 3 and in another call it is becoming 3 2 4 or something like that? Is there anything that is changing? No, obviously. So weight is constant, value is constant, right? Now is this n changing? Yeah, exactly, Miral. That's very correct. We are just checking if we want to consider it or not. Okay, we are not changing the array. All right. So is this value n changing? Yeah, this value n is changing as well. So we have two parameters that is getting changed. So thus we can conclude that we need a 2D DP. All right, the dimensions of the DP, and one dimension will representing weight, other dimension will be representing the size. All right, that is how we decide that what will be the dimensions of the DP. Cool. Let us now. So that's how I have formed this 2D DP. Done. Okay. Now let us come back to the code part. So now let us see. Okay. So let us now take it as I. Okay, not n. Why? Because this value will be getting changed. So using, and let us say when we have passed it in the main function, it was initially n. Okay. And here we are taking it as I. Okay. So this is how, let us say, our function is. Right. Now what we will do, first of all, we will check if t at I w is not is equal to, let us say, first of all, we have initialized it with -1. Okay, is not equal to -1. Okay, is not is equal to -1, then can we say that we need to return t at iw? Is this statement clear? Yes, storing calculated result. We'll first check, like we are having a 2D array here, okay, which is t. Okay, now we will first check that whether the value at I and W has been already calculated or not. Yes, exactly. Thanks, Nikaj, for telling me about the base case. So here the base case will be like we are decreasing the value of I, right? So if at any point of time I is becoming less than 0, then we can simply return 0. All right. This is going to be our base case. Okay, so after base case, we will check if t at iw is not is equal to -1. Okay, so if it is not equal to -1, it means what? That it has already been calculated. So if you have calculated it, it means that you can simply return this value from this point. Clear these two lines, these three lines actually. If I is 0, then we can iterate it like this. Indexing starts from 0. So the base case will be if I is less than 0, then you need to return 0. Okay, can we use unordered map to store data? Right. Okay, we can try using that. But then, okay, see what will happen in an unordered map? We store it in a key value kind of thing, right? In if you store it in unordered map, then maybe you will be facing problems while you are comparing the values, right? In that case, there might be some issues. So herein we prefer using 2D DP array, right? Because it makes the comparisons easier. Now let us see what was the next condition in the recursive approach. We were checking that if the current weight is greater than the maximum capacity, right? So herein as well we will check the same thing, that if the weight of the current item is greater than the maximum capacity. Okay, in that case, first of all you need to calculate what you will store in T at IW. That will be, we are not adding the item. So if you are not adding the item, then simply call the knapsack for W, weight, value, and I-1. Okay, why I-1? Because we have excluded the item, right? And we haven't subtracted anything from weight because the item has not been added, right? And once you have stored this value in T of IW, you can simply now return T of IW from here. At every point of time, you need to return the value stored inside the array. Keep that in mind. All right. Is this line clear? What we have done here? Let me know, everyone in the chat section, please, if this line is clear to you all. This is when item has been excluded. Okay. All right. Now, the next thing was if the weight is less and when we are adding the item. Okay. What we will be doing in that else condition. First of all, see in recursive call, what we were doing, we were directly where it went. Okay, so all right. In the recursive call, what we were doing is we were directly returning the values, right? Like return knapsack, return max of whatever it is. But in the memoized approach, what you need to do is just before returning, simply store it in an array, right? So that is what we are doing. Before returning, we are simply storing it inside our array as we are doing it here. Okay. Every time you are returning this, what you are doing is first of all store it and then return it. Okay. Now, in else, what we'll do simply again, you need to just calculate t at iw. It will contain the maximum of. Okay. Let us say we have added the value at I plus call the knapsack function, or the value has not been included and call the knapsack function for the original, like in this way. Okay. So that is what you will store in t at iw, and then you can simply return t at iw. Okay. The calculated value. That is it. Okay. So is this clear? This else state? This is how we have done memoization, and let me highlight the part where we have memoized actually. So the first part is this. We are checking if T of IW is not -1. Thanks, Shishir, for the confirmation. And the second part where we have used memoization is this. And the third part where we have used memoization is this. So there were 3 calls that were being made, right? Now in memoized approach, all of these 3 calls are stored inside 2D array, right? So that is why it is known as memoized approach, because we have remembered the value that have already been calculated. Okay, is this approach clear to you all? If yes, then please help me with the time complexity and space complexity of this code. All right, everyone, let us see if you all can figure out the time complexity and space complexity of this code. Okay, so Naikaj is saying that space complexity is linear, okay? Okay, time complexity is linear and space complexity is n square. Let us see. Okay, first of all, let us discuss space complexity. It is very clear that we are using 2D array, right? So the space complexity will be n into w plus n. Why this plus n is there? Can anyone tell me? This n cross w is for 2D array. Why this n is there? Because of the recursive stack. Okay, exactly, because of the recursive call function. Okay, and the time complexity of this code, that is going to be simply n cross w, because we are filling out our 2D array, right? And to fill, the size is n cross w, so it will take the n cross w time to fill it out, right? So this is the time complexity, this is the space complexity for the memoized approach. Clear to you all? You all can take your time to analyze this. No hurry. Just try to figure it out how things have been done. Okay. Clear? It's okay, Nikaj. It happens sometimes. All right, everyone. So, just taking into consideration some time constraints, I think I am not going to code this memoized approach. If any of you want it, all of you can try do coding it. All right. If any issue occurs, do let me know. I'll be very happy to help. I hope every one of you have joined the Discord channel as well, where we discuss the questions, POTD, and the weekly contest series that we have. Okay, we keep on discussing that. So. All of you, what you can do is you can code this memoization approach, and then if there is any issue, then do let me know. All right, for now let us now move to the final approach that we have, that is the DP approach. Okay, the concept of memoization is clear, right? That what we are doing there. Simply store the pre-computed values. Okay, whatever there was in the recursive code, write the recursive code as it is, and then before returning the recursive code, make sure that you are storing it inside a 2D array. Okay, that is the memoized approach. All right, cool. Now DP approach. Okay, so in DP approach, what we are going to do is exactly like this. We will be using here bottom up approach. So we are going to fill up the table. Okay, now initially we will be, let us take two parameters I and j. Okay, let us say I is representing total number of items and j is representing the current weight. Okay, I is representing actually not the total number of items, that is represented by n. So I is basically representing the index number of current item. Okay, current weight, and I is current index value, right? So we will be starting from I0 and J0, all right? And then we will be moving till I is less than is equal to N and J is less than is equal to W, right? Let me start coding. That will be more clear, because as we have already seen the recursive approach and memoized approach, so this will not be very difficult to understand. Okay, so first of all, what we need to do is we need to create a 2D vector. Okay, so vector int of size n plus 1. Yeah, exactly. We are going to fill the table. Vector int of size. The maximum value that we can going to do is w plus 1. Okay. And now for int I is equal to 0, I is less than is equal to n, I plus plus. For int j is equal to 0, j is less than is equal to w, and j plus plus. All right. So what was the base condition while we were writing the recursive code? If the item has been reduced to 0 or if the capacity is 0, right? So in this case, if I is 0 or if j is 0, right? This represents the base case of the recursive condition that we have written. Okay. So if I is 0 or j is 0, then in that case, T of ij will be getting filled as 0. Okay. Is this line clear? The line number 19 and 20. Is it clear? If I is 0 and j is 0, simply fill it with 0. Okay, this is the base case of our recursive condition. All right. Now, else if the current weight that we have, okay, if that is exceeding, well, let us say it is less than the maximum weight that we can have. Okay, that is j. Okay, it will be I minus 1. Okay, all right. So if the current, let us say the current weight that we are evaluating, okay. So if weight at I minus 1, if it is less than the current weight, then what we fill it as? We fill it as max value, right? We compare. So T of ij is going to be max. Let us say we have added the value. So if you have added the value, then it will become value at I minus 1 plus T at I minus 1. Yeah, all right. We are adding it, and W, sorry, the current weight that we have minus weight at I minus 1. Okay. Either this or E at I minus 1 and G. Okay. So what we have done here is, first of all, we are checking if weight is less than the maximum capacity. Okay. In this case, the maximum capacity that we have till now is J. All right. So if J is the maximum capacity that we have, and let us say you have included the item. So if you have included the item, then value of that item will get added. Clear? And the weight of that item will get subtracted from the maximum weight that we have, right? And the current maximum weight that we have is J. So that's why we are subtracting weight at I minus 1 from J. Okay. This is when the item is added. Now, when the item is not added, what you will do, simply do I minus 1, but do not subtract the weight from J, right? Because we have not added it. Okay. So there will be no any effect in J. All right. So this is how we will fill if the weight is less, or else if the weight is greater, then what we are going to do is simply will not add the item, right? And then at the end we can simply return the maximum value was n, and here the maximum value was w, right? We just compare and run this. Okay. All right. So everyone, please look carefully into this code and let me know if there is any issue that is persisting. This is, we have filled the table in the bottom up manner. This is the DP approach. All right. And share the code. All right. Let me open online GFG editor. So if I will copy and then see this and then paste. All right, guys. Okay, what did I do? Okay, so this is the bottom-up approach. With what that was our final aim for this question, to start from the recursion and then to reach till the memoization. You all can see how it is related to the recursive approach. This resembles the base condition, okay, for the recursive code. This resembles the condition when the item was not included, item excluded actually, because the weight was greater. And this resembles the condition when item weight is less, but we need to make a choice. We need to make an optimal choice, okay? Right? So that is how it is resembling the recursive approach. And then starting from recursion, we reach till this point, all right? Any confusion, any doubt, just analyze this code and try to understand it. If there is anything that you are not getting, please feel free to ask. And also, I'm very happy to see the enthusiasm that all of you are showing. Like it's being active at this time. Like actually, it's kind of getting colder every day. So all right, before we move on to our next question, can anyone please quickly drop down in the chat section like what is the temperature of the place where they are living right now, along with the name of the place. Let us see who is living at the coldest area amongst us. I'll also drop mine. So I'm in currently Kolkata and we have a temperature of around 19, I guess. All right, so all of you can drop it down in the chat section. Okay, in Meerut also it is 19. Okay, Faisal, so it is colder in Kashmir. Obviously, Kashmir has to be the coldest place. Porbandar, it is 21 degree. Okay, so that is kind of good. Nice weather, I would say. Faisal, would you like sharing the temperature with us? Yeah, okay, it's 3 degree. Last year, I was in Srinagar at this time, and yeah, it was actually quite cold there. I witnessed snowfall as well. Okay, so currently Faisal is the winner for being in 3 degree. Okay, 18 in Rajkot. Agra 5 degree. It has reached till this. All right, we have 11 degree as well. Porbandar 22. All right, so my father is currently posted in Manali, and there the temperature is like around minus 15 to minus 20 degrees Celsius. So I guess he's the winner. But then, yeah, as I say, thanks everyone for yes, I know Porbandar, a coastal area, I guess, right? All right, guys. So that's really great. You all are working hard even in such extreme climatic conditions. Like right now, the weather conditions are not so much favorable. All right. So enough discussion about weather conditions. All of you stay safe. Like take care. Take the needed precautions before any of you catches cold. All right, let us now move to our next question. That is unbounded knapsack. Okay, so we are clear with 01 knapsack, right? That is clear to us. Now we are going to move to unbounded knapsack. Knapsack with duplicate items. Why unbounded? Because you can add an item again and again. Okay, in 01 knapsack, it was like if you are added an item once, you can't add it again. But here you can add it again and again. Cool. So there is not much difference. Let me just copy paste the code. All right. Okay. So as we are able to add the item again and again, so there will be difference at only one point. So can anyone tell me what difference it is going to be? As we can add an item again and again, so there is only one change that we are going to make here. What is that change? Okay, line number 23, that's great, Nikaj. So in line number 23, when you have added an item, as you can add it again, So you don't need to do this I minus 1, right? It will just be I. Okay, see, when you have excluded an item, there is no any chance that we are going to add it again. But when you have added an item, you can add it again and again as well. Okay, so that's why rather than writing here I minus 1, we will only be writing I, and thus the question will be for unbounded knapsack because we are including the item again and again, right? Okay. So this is the code for the unbounded knapsack. I hope it is clear to you all. So all right guys, that was all about that we had for the knapsack problems. And yeah, as I said, we have a fractional knapsack as well. But as it is a greedy approach, so we are not going to discuss it in this series. So what happens basically in fractional, if you want, you all can try it, okay? So what happens basically in fractional knapsack is you have to sort the elements. How? On the basis of ratio of their weight and value, right? Sort it, and then you can keep on adding it till you reach the maximum weight. All right, so that is the approach we are going to follow for fractional knapsack. Cool. And here, we can break the items, unlike what we were doing in 0, 1 and unbounded. Okay, so okay, yeah, this is the code for unbounded knapsack, and the previously I shared the code for 0, 1 knapsack as well. Please let me know if we have any issue related to the knapsack problems. Tomorrow what we will be doing is we will be discussing the questions that are based on the concept of knapsack. Okay, all right, any issue in today's session or any feedbacks, anything that you want to add, please feel free to drop it in the chat section. I will be very happy to look at it. All right, thanks Nikaj. Good night to you too. Okay, all right everyone, so that was all about today's session. I hope all of you liked it, all of you were able to understand the concepts, and it will be of some help in your preparation journey. So everyone, please keep up the hard work, stay connected with us, and do join us for tomorrow's session as well. We will be solving more interesting questions. And thanks everyone for joining. Take care, stay safe, and yeah, bye everyone. Good night.